Bismillahir Rahmanir Rahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum students. This is Hamza Noor, and today here we have some questions from the topic arithmetic progression and geometric progression, ASP1, Pure Mathematics 1. And here we have some questions from the past paper handout. First of all, we have question number 18. Part A is saying that the sum Sn of the first n terms of an arithmetic progression is given by Sn is equals to 32n minus n square. Find the first term and the common difference. Okay, so the expression for the first n terms of this arithmetic progression is given by 32n minus n square. So first of all, if I want to find actually the sum of the first one term, sum of the first one term actually means the first term of the arithmetic progression itself, because it makes sense. Okay, so 32 times 1 and then take away 1 square, so this is supposed to be 31. So therefore I can say that the first term is 31 because the sum of the first one term is actually 31. Now if I put n is equals to 2, so actually I'm trying to find out the sum of the first two terms, right? So 32 times 2 minus 2 squared, so this is basically 64 minus 4, which is equal to 60. The sum of the first two terms is basically equal to 60. So for example, if you have an arithmetic progression like this, that first term is a, the second term is b, for example, so you can say that a plus b is basically equal to 60, because 60 is basically the sum of the first two terms. So if I want to actually find the second term of this arithmetic progression, so what I'm going to do is subtract 31 from 60, isn't it? Because 60 is the sum of the first two terms and the first term is actually 31. Okay, so if I want to find the second term such that the sum of the two terms turns out to be 60, so therefore I have to do 60 minus 31, that is 29. So therefore I can say that the second term of the arithmetic progression is actually 29. Now what we need to find the first term, which is actually the first term we have already found. Okay, that is 31, and the common difference, and since we know the fact that the common difference is equals to term 2 minus term 1, so 29 minus 31, the common difference is -2. This working is for 3 marks. Okay. Then part B. Part B is saying that a geometric progression in which all the terms are positive has sum to infinity of 20. The sum of the first two terms is 12.8. Find the first term of the progression. So let me just erase this whole working. A geometric progression in which all the terms are positive has sum to infinity of 20, meaning a upon 1 minus r is basically equals to 20. The sum of the first two terms is equals to 12.8, and since we know the fact that sum of n terms is equals to a multiplied by 1 minus r raised to the power n upon 1 minus r, and you can also use this formula as well. Sum of n terms is equals to a multiplied by r raised to the power n minus 1 upon r minus 1, because you will get the same answer from both of these formulas. Okay, so basically we need to actually find the first term. Okay, all right, so basically sum of the first two terms is 12.8, so 12.8 is equals to a multiplied by 1 minus r raised to the power n upon 1 minus r. Okay, 1 minus r raised to the power a multiplied by 1 minus r raised to the power n upon 1 minus r. So basically we can solve the equation over here if we make a the subject in the first equation. So a is equals to 20 multiplied by 1 minus r. We can actually substitute this equation into the second equation. So 12.8 is equals to a multiplied by 1 minus r raised to the power n. So basically r raised to the power n, and since we know the fact that 12.8 is basically the sum of the first two terms, so this is basically r squared. This is basically r squared, so 1 minus r squared upon 1 minus r. All right. And in place of a, we can actually write 20 multiplied by 1 minus r. So 12.8 is equals to a multiplied by, in place of a, we can write 20 multiplied by 1 minus r, and then multiplied by 1 minus r squared, and then divided by 1 minus r. So basically 1 minus r and 1 minus r are cancelled out. Therefore, you can say that 12.8 is equals to 20 into 1 minus r square. So if you make 1 minus r square the subject of the equation, so this is 12.8 divided by 20, and which is 16 over 25, meaning 0.64. So 1 minus r square is basically equals to 0.64, and making r square the subject, r square is equals to 1 minus 0.64. Okay, so this is 0.36. R square is equals to 0.36. So r is equals to plus minus under root of 0.36, which is actually 0.6. So since we know the fact that all of the terms of this geometric progression are positive, so obviously the common ratio is also supposed to be positive. Therefore, r is equals to 0.6 is the only acceptable answer. R is equals to minus 0.6 will be ignored. Okay. So this was basically question number 18. Let's move on to the next one. Question number 19. Question number 19 is saying that the first, second, and the last terms in an arithmetic progression are 56, 53, and minus 22 respectively. Find the sum of all the terms in the progression. Okay, the first, the second, and the last terms in an arithmetic progression are 56, 53, and minus 22 respectively. So this is an arithmetic progression. So a is equals to 56. The second term, in the place of second term, we can actually write a plus d. Why? Because Tn is equals to, the formula for the specific term is a plus d times n minus 1. So if you actually want to find the second term of the progression, so T2 is equals to a plus d into 2 minus 1. Therefore, you can say that the second term is actually a plus d in terms of a and d. But since we know the fact that the first term is equals to 56, so in the place of the second term, we can actually write 56 plus d. 56 plus d. But the second term is actually 53. Okay, the second term is actually 53 itself. So since we know the fact that 53 is equals to 56 plus d, therefore we can say that the common difference is supposed to be minus 3. That is 53 minus 56. And the last term is basically minus 22. We know the first term of the arithmetic progression. We know the common difference, which is minus 3. We can actually find how many terms are in this arithmetic progression. So, and since we know, since we know the last term of this progression, so the specific term formula is Tn is equals to a plus d times n minus 1, and minus 22 will be equated to 56 plus minus 3 times n minus 1. Now we can actually find the number of terms which are in this arithmetic progression. Okay, because that n, the value of n is very important, because even if you apply the formula of n upon 2 multiplied by a plus l for the sum of n terms, so obviously you need to know the value of n, right? You need to know how many number of terms are actually in this arithmetic progression. So just solve this. Minus 22 is equals to 56 minus 3n plus 3. Okay, making 3n the subject, so 3n is equals to 56 plus 3 plus 22. So 56 plus 3 plus 22, and then divided by 3, n is equals to 27. Now we can say that there are basically 27 terms in this arithmetic progression. Now we need to find the sum of all the terms in this progression. So the formula is Sn is equals to n upon 2 multiplied by a plus l. Because we are using this formula. Why? Because we actually know the last term of this arithmetic progression. So sum of these 27 terms is supposed to be 27 over 2 Okay, I'm just erasing this working below. So sum of 27 terms is basically equals to 27 over 2 multiplied by a plus l. So the first term was 56 and the last term is negative 22. And this is 56 minus 22 multiplied by 27 divided by 2. 459 is the sum of all the terms in this arithmetic progression. This was the complete requirement for 4 marks. Now part B is saying that the first, second, and third terms of a geometric progression are 2k plus 6, comma 2k and k plus 2 respectively, where k is a positive constant. Find the value of k. The first, second, and the third terms of the geometric progression. Okay, so basically the first term is 2k plus 6. The second term is basically 2k, and third term is basically k plus 2. And since this is a geometric progression, here we have to deal with the common ratio. Okay, and since you know the fact that common ratio is basically equals to term 2 upon term 1, which is also equals to term 3 upon term 2. So we can actually form an equation in terms of k by using this formula. So term 2 upon term 1 is basically 2k upon 2k plus 6, and this will be equals to k plus 2 upon 2k. Now you can basically do the cross multiplication over here. So 2k into 2k is 4k square. This will be equals to k plus 2 times 2k plus 6. Just expand this completely. Let me just zoom in over here a little. Now basically you will get a quadratic equation in terms of k. So 4k square is equals to 2k times k is 2k square, and then k into 6 is 6k, and then 2 times 2k is 4k, and then 2 times 6 is positive 12. Therefore we can say that 4k square minus 2k square minus 6k minus 4k minus 12 is equal to 0. So 2k square minus 10k minus 12 is equal to 0. We can make this quadratic equation more simplified by taking 2s common. I mean taking 2s common. And what else you can say that each of the term in this quadratic equation can be divided by 2. Okay, so k square minus 5k minus 6 is equal to 0. So we can actually factorize this as well. This sign tells us that we have to do the subtraction, and after the subtraction the middle term is supposed to be minus 5. So k minus 6k makes sense. So k square plus k minus 6k minus 6 is equal to 0. Taking k as common multiplied by k plus 1, taking minus 6 as common multiplied by k plus 1, and this whole thing is equal to 0. Therefore, k plus 1 multiplied by k minus 6 is equal to 0. I mean, there are two values of k over here. K is equal to minus 1 and k is equal to positive 6. But we need to look at the condition which is mentioned in the question. It is said that k is a positive constant. So minus 1 will be ignored and k is equal to 6 is the only acceptable answer. All right. So this was basically question number 19, part B, part 1. Now part 2 is basically saying that find the sum to infinity of the progression. Okay. Let me just erase this whole working. Sum to infinity of this progression, and since we have found the value of k which is equal to 6, so we can actually write down the first three terms of this geometric progression. So 2k plus 6 comma 2k comma k plus 2, and 2 times 6 plus 6 comma 2 times 6 comma 6 plus 2. Okay, just write down the first three terms. 6 times 2 is 12, 12 plus 6 is 18, 18, 12, and 8. Okay, these are the first three terms of the geometric progression. Now we need to actually find the sum to infinity. The formula is a upon 1 minus r, and since you know the fact that the common ratio is either term 2 upon term 1, or you can say term 3 upon term 2. So the common ratio is 12 over 18, or you can say 8 over 12. 12 over 18, meaning the common ratio is 2 over 3. Okay, and a upon 1 minus r, so 18 upon 1 minus 2 over 3. Just write this whole fraction in your calculator, and therefore the sum to infinity, your final answer is supposed to be 54. Sum to infinity is equals to 54. So this was basically question number 19.